find the unknown side of the right triangle, we're just going to use Pythagoras. So we know that the square area from each side, the shorter two sides, equals the square area from the long side. So I'm going to write it like this. I'm going to take 17 squared, and I'm going to take away the square from one of the shorter sides. And that's going to give me the square from the other shorter side. So 17 squared is 289. 14 squared is 196. And so when we subtract those, we end up with x squared is equal to 93. Okay, so I haven't found x yet, I've just found x squared. So if I want to square root both sides of that, to undo the square, I end up with x is equal to the square root of 93. And as a decimal, that's approximately equal to, okay, and again, I prefer the root form, but if you work out the decimal value, it's approximately equal to square root 93 is 9.64. Here we have surface areas and we want to draw a net. So we need to make sure we account for all the surfaces. So I'm going to do it this way. So I'm going to have my bottom surface. I'm just going to shade that to indicate that's my bottom. Actually, I'm going to do different shading here. I'm going to highlight it. I'm just going to shade that. That just represents the bottom surface. Okay, and then from the bottom, I'm going to draw out the side surfaces, which is going to be the L-shaped pieces. Okay, now the proportions are a little bit off. Maybe I'll just draw this a little bit better proportionally. So I'm just going to kind of shorten this up a little bit. Make it a little bit more proportionally accurate. Okay, so then I get more of a shape that kind of looks a little bit more like that. Okay, so then from that, I'm going to draw my front edge, which is a toe. Okay, so I'll maybe just color code that. That edge there is going to be this edge here. Okay, then I'm going to draw the top of the foot there. I'm going to draw the back on this side. Okay, and then this front piece here, I'm just going to call the shin. That's going to be this piece here. And then there's a very top piece, which is going to be this piece here. Okay, so I've accounted for all my sides. There's my net. Okay, and then I'm just going to calculate the different areas here. I'm going to start with the bottom area. So I know that the distance across here is going to be 1 plus 2, or 3 centimeters. So that gives me 24 centimeters squared here. On the toe, it's going to be 1 centimeter this way by 8 centimeters. So I'm going to get 8 centimeters squared. The surface up top here is going to be 2 by 8, so 16 centimeters squared. This area here is going to be the same, 16 centimeters squared. It's going to be 2 by 8. The top is going to be 8 centimeters squared. Okay, along the back side, we need to know this length here. So we know that it's going to be 3 centimeters. So this back side represents 3 times 8, or 24 centimeters squared. Okay, so I've accounted for those sides. I now have to account for the side surface. Okay, this surface in here, it's hard to see that. This surface in here, I'm just going to break it up into 2 pieces here. It's going to be 1 by 3, so 3 centimeters squared. And then this top piece is going to be 2 by 1, so 2 centimeters squared. So that's a total of 5 centimeters squared for both back and front. So to calculate the surface area, I just sum this all up. So 24 plus 24 plus 8 plus 16 plus 16 plus 8, and then plus 5 plus 5. Okay, taking the sum of that, well, I'm just going to group this together. This is going to be 10. This will be 24, 24. So I'm going to have 4 groups of 24 plus the extra 10. And so that's going to give me 96 plus 10, or 106 centimeters squared. And that's going to be the total surface area of that object.